The food we eat has changed a great deal in the last century. From the kind of food we grow, to the farms it's grown on, to the process of getting it from farm to table. But one of the biggest changes to global agriculture isn't so much about the food itself. It's about the water we use to grow it.
Over the past century, we've gone from a situation where farmers depended almost exclusively on rainfall for their crops to a realization that they could use irrigation to maximize crop output and grow crops in areas that may be too dry for where they would naturally be able to grow.
That shift comes with new responsibilities. In some areas, people are using water faster than it's being replenished. NASA satellites help us see how water moves from ocean to atmosphere to land, where we harness it for growing food. The big picture view they provide helps us understand how our water needs are being met today and where we might find ourselves short tomorrow. Increasingly, we're tapping into groundwater from underground aquifers to meet our demand. These aquifers, vast regions of water-saturated earth, can be huge, but hidden underground, they're difficult to observe. How do you study what you can't see? The unlikely answer: go to space. A pair of satellites called GRACE is on a special mission. They're carefully mapping delicate variations in the Earth's gravity. Our planet's gravity isn't the same everywhere. Objects with larger mass, mountain ranges for instance, exert a stronger pull. So do huge bodies of water, like aquifers. As the GRACE satellites orbit together, large objects affect the leading satellite before they affect the trailing one, causing the distance between to vary. By taking continuous measurements of that distance, scientists can map the Earth's gravity field and see how it changes over time. And over land, the major cause of that variability is changes in the amount of groundwater. GRACE effectively feels those changes by monitoring gravity.
So changes in groundwater are actually sensed by GRACE, and we can come up with estimates of the water table variations. And that's what we did for Northwest India.
In India, water-hungry farms in the nation's north draw 95% of their water from groundwater stores. Since GRACE's launch in 2002, aquifers beneath northwest India have lost a staggering amount of water. 3 times as much water as is held in Lake Mead, America's largest reservoir, is gone.
The people of India know this is happening. They know this because their wells occasionally run dry and they have to dig a deeper well. In some cities, the wells are running dry so fast that people spend their entire day trying to find a clean source of water for their family.
If the aquifer continues to decline, the region's agriculture faces an uncertain future, as do the almost 115 million people who live there. India's not alone. Other major aquifers, like those beneath northern China and the central US, are also in decline.
Water is critical to people. I mean, it's a vital resource, obviously. So being able to understand the water cycle and how it's changing is important as we move forward in a highly populated world with potential climate change going on. And NASA satellite observations are extremely valuable to getting an unbiased view of what's going on with the water cycle.
Water resources will become even more scarce in the coming century. The GRACE satellites can't help us recoup what we've lost, but they do give us something valuable: knowledge we can use to shape our future in an increasingly hungry and thirsty world.